we are given a matrix A inverse, another matrix B, and we have to find out A, B inverse. So we'll make use of this result that the inverse of the product of two matrices is the product of their inverses but in the reverse order, that is equal to B inverse into A inverse. Now what you notice here that A inverse is already given, so we have to find out B inverse. And what is the definition of B inverse? It will be 1 by determinant B into adjoint B. So let us first of all find determinant B and then adjoint B. You are given matrix B, so what will be the value of determinant B? It will be determinant 1, 2, minus 2, minus 1, 3, 0, 0, minus 2, 1. Now, because in column 3, you have 1, 0, so it is better if we expand this determinant B, expand along C1. So you get 1 time, delete the row and column through 1, you get 3 minus 0. And then minus, minus, plus 1 time, delete the row and column through minus 1, you get 2 and minus 2 into minus 2, 4. So 2 minus 4. So you get 3 and 2 minus 4 is minus 2. So finally you get 1. So hence we have got the value of determinant B as 1. This will substitute when we write the value of B inverse. And now let us start finding adjoint B. How do you find adjoint of a matrix? It is the transpose of cofactor matrix. Let the cofactors are C11, C12, C13, C21, C22, C23, C31, C32, C33. How do you get a cofactor? Delete the row and column through that element and then take the value of the determinant of the remaining matrix with proper sign. What are the proper signs? Plus, minus, plus, minus, plus, minus, plus, minus, plus with these signs respectively. So you get the value of adjoint A, it will be transpose of, how do you get C11? C11 will be, delete the row and column through 3 and you get 3 minus 0, so plus times 3 minus 0. And then minus times, delete the row and column through 2, you get minus 1 minus 0. And then the third element of row 1, of course, of matrix B, that is minus 2, you delete the row and column and you get through minus 2, you delete the row and column, so you get 2 minus 0 and of course outside plus. And similarly, you write yourself the elements of second row and third row as minus outside, 2 minus 4 and then plus times 1 minus 0 and minus times minus 2 minus 0. The elements of the third row will be plus times 0 plus C and minus times 0 minus 2 and plus times 3 plus 2. So you get adjoint B we are trying to find out, transpose of, by working out the numbers in the previous step, you get 3, 1, 2, 2, 1, 2 and the elements of the third row will be 6, 2, 5. Take transpose of it, you get the elements of the first row, you write in the first column, the elements of the first row, that is 3, 1, 2, you write in the first column, elements of the second row, 2, 1, 2, you write in the second column, and elements of the third row, 6, 2, 5, you write in the third column. So now the value of adjoint B is 3, 2, 6, 1, 1, 2 and 2, 2, 5. So we have got adjoint B also. So now we are in a position to write B inverse as 1 by determinant B into adjoint B, which we have just worked out. What is the value of determinant A? That is 1. So into adjoint B. What is the value of adjoint B? You worked out just now. It was 3, 2, 6, 1, 1, 2 and 2, 2, 5. So yes, we have got the value of B inverse. Outside the 1 by 1 will not matter. So the matrix will remain B inverse. And now let us substitute it in 1. So you get from 1, that is the required AB inverse is B inverse into A inverse. Get the value of B inverse from second. So what is the value of B inverse which we have worked out in second? It is 3, 2, 6, 1, 1, 2, 2, 2, 5 multiplied by A inverse. A inverse is already given to you. Just note down from there. It is 3 minus 1, 1 minus 15, 6 minus 5 and elements of the third row are 5 minus 2, 2. And now it is a matter of multiplication. And you know multiplication of the matrices, this being of order 3 by 3, both the matrices being of the order 3 by 3, the resulting matrix, the product will also be of the order 3 by 3. So now by now you have multiplied. So AB inverse, you know very well how to multiply two matrices. You know, you multiply the elements of the first row with the first column and you get the first C11 element of it. The 1 1 element, it will be 9 minus 30 plus 30. And the second element of the first row will be obtained by multiplying first row with the second column and you get minus 3 plus 12 and minus 12. And in the third column of the third element of the first row is 3 minus 10 plus 12. And now repeat the process with the second row and multiply to column 1, 2, 3, you get 3 minus 15 plus 10. Multiplying the second row with the respective elements of the second column, you get minus 1 plus 6 minus 4. And with the third column, you get 1 minus 5 plus 4. And now repeat the process with the elements of third row, 2, 2, 5. Multiplying to the first column of the second matrix, you get 6 minus 30 plus 25. Then multiplying to the second column, you get minus 2 plus 12 minus 10. Multiplying to the third column, you get 2 minus 10 plus 10. Just work it out and you get finally AB inverse equal to. Just work out these numbers. You will get 9 minus 3 and you get 5. The second row you have minus 2, 1, 0 and 1, 0, 2. So that is the value of required AB inverse. AB inverse is this matrix.